This is the video notes that go with solving and checking ax plus b equals cx plus d. Go ahead and copy down your title and look at your remember, okay? Write that down. And again, as you're going through the video, anytime you need to stop and pause the video, please feel free to do that. You can rewind it, replay it as many times as you need, okay? Now, if you notice these equations have x's and constants both on the opposite sides of the equals, okay? You have x terms and constants both on each side of your equal sign. Again, this is a new type of problem for 8th grade, so you've not have really seen much of this before. So let's talk about it. If I put in my river, I want you to notice something. 1, 2, 3, 4. All 4 of these are exactly the same problem. Okay? Because I wanted us to have the discussion about the fact that there is 4 ways you can work these problems. Now, I want you to just imagine for a minute. You need to get your x's on one side of the river, the numbers on the other side of the river. Okay? Now, notice I didn't say you had to put the x's on the right side or the left side. I didn't say you had to put the numbers on the left side or the right side. I just said you need to get your x's on one side together and your numbers on the other side together. Okay? So you're going to have to move one of the x's and you're going to have to move one of the numbers. Now, which one you move first and which one you move second, it's all just a personal choice. Okay? So with that said, there is actually 4 ways to work these problems. And no one way is any better than the other, and you can work in 4 different ways and still get the exact same correct answer. Okay? Now, let's take a look. What do I mean by that? Okay? So let's focus right here. Okay? Now, I want to just start off right here. I've got 4x plus 8 equals 2x plus 12. This time, I think I want to take the 2x and subtract it from both sides. Now, that is going to let me put that x term on that left side together. Okay? So over here, I'm going to have 4x minus 2x, which is 2x, okay, plus the 8, okay, equal to, now on this side, we know those 2x's are going to cancel out because 2x minus 2x is 0, and that's going to bring me down a 12. Now, when I get to this point right here, I'm at those same last 2 steps that I said we just about do every single time. Almost every single time. So we know that we got to subtract the 8 from both sides. Okay, so I'm going to bring down my 2x. My 8's are going to cancel each other out, equal to 12 minus 8, which is 4. Now I'm writing so big, I'm going to run out of room here. Sorry about that. So I'm going to divide both sides by 2, and what I have is x equals 2. Okay. Now, that is one of my 4 ways to work it. Okay. Let's talk about a second way to work it. And I'm still going to think about my x's in this one. Right here, I put the 2x, I moved it from the right side over to the left side. Okay. But what would have happened if I'd wanted to put the 4x from the left side to the right side? Take a look. What's going to happen right there? Well, I'm going to have 4x minus 4x, which is 0, so it cancels out. And that means I bring down my 8. Okay? And just want to do this. If you want to, you can just cancel it out. Now, over here on this side, I'm going to have 2 minus 4. 2x minus 4x. So 2 minus 4 is negative 2. And I keep the x. And then I'm just going to bring down that plus 12. Now, take a look what I got right here. I need to now, since that last 2 steps, I need to move the 12 over with the 8, don't I? So since that's plus 12, I'm going to subtract 12. So minus 12. Okay? Now, 8 minus 12 is negative 4, equal to negative 2x, and then we know these 12s right here are going to cancel each other out. Then what's the last step? Divide by that negative 2. And again, I'm writing so big I'm going to run out of room. So right here, I'm going to have negative 4 divided by negative 2, which is positive 2, equal to, and then those 2's are going to cancel out, and that leaves me with x. Well, look what happened. Over here, x is equal to 2. What's x equal to right here? 2. Okay, now look, how are those problems different? The only difference is in this one, I put the x's on the left side. Over here, I put the x's on the right side. And this one did have some more negatives in it, but did it change my final answer? No. Now, you're sitting there thinking, okay, I agree with that. That's 2 different ways. But how in the world do you get a third and fourth way? Well, that comes from the fact that I may not want to move the variable first. See, in these 2 methods, I moved the x's first. What if I decided I wanted to focus on the 8 or the 12? Okay, what would happen if I moved those first? Okay, so let's look at this one. Let's do that. Let's move this 8 first. So we're going to decide, well, I'd rather just go ahead and think about putting the 8 over here with the 12, just like that. Okay, now that means I have 4x right here. The 8 minus 8 is going to cancel each other out, equal to, bring down my 2x. Now right here I've got 12 minus 8, which is 4. So plus 4, just like that. Now, what am I going to have to do next though? I got to get this 2x now over here with the 4x, don't I? Because I got to get those 2 on the same side. So now I'm going to subtract the 2x, just like that. And I'm going to have 4x minus 2x, and that's going to give me 2x, equal to, we know these are going to cancel each other out right there, and that's going to give me 4. If I divide both sides by 2, I have x equal to what? 2. Just like that. Oh, wow. Same right answer. Okay? And I want you to know, has anybody noticed these 2? Up here, I subtracted the 2x first, and then I subtracted the 8. What did I do down here? The complete opposite, didn't I? I subtracted the 8, and then I subtracted the 2x. So these had exactly the same 2 steps. They were just in a different order. That's okay. Okay? Now, that's way number 3. Well, what about number 4? Well, the 4th way comes from the fact that, what if I wanted to move that 12 first? Well, if I wanted to take care of the 12 first, that means I'm going to subtract the 12 from both sides, just like that. Put my line underneath there, and I'm going to bring down my 4x. Then I'm going to have 8 minus 12, which is negative 4, so I write minus 4, equal to, bring down my 2x right here, and we know these 12s are going to cancel each other out. Okay, now in my next step, what I've got to combine is the 2x's, don't I? So since my 4 is already on the left side, I need to take the 4x and park it over on the right. So I'm going to do that by subtracting the 4x, just like that. Put my line right there. We know 4x minus 4x cancels out, and I've got negative 4 equal to 2 minus 4x. That's going to be negative 2x. And then what's going to happen? I'm going to divide by negative 2, and that's going to give me x. These 2's are going to cancel out, but negative 4 divided by negative 2 is positive 2. Now, I want to stop here again and say, I'll just work the exact same problem 4 different ways and got the exact same correct answer. Why this works is because we have 4 terms, we have x's on both sides, we have numbers on both sides. You just got to move them around so that the x's end up together and the numbers end up together. It absolutely does not matter which term you move first. You got 4 options, 1, 2, 3, 4. I can move any one of those 4 first. That's why I have 4 ways to work that problem. Now, oh my gosh, you're sitting there thinking, oh my God, she's going to make me do this 4 different ways every single time. No, I want you to pick one way and solve it. But I want you to realize that if you look at a friend's work, a neighbor's work, or somebody else's work, and just in general, they may not have the exact same work, but you may have the same answer, and both of you being correct how you get there, because there is 4 ways to do these problems correctly. Okay? Now, I want us to do a couple of them together and check them, now that we've kind of got an idea going here. So we're going to come down here. This is example 3, or example 2, sorry. I just let those first 4 be example 1. And then we'll have an example 3 down here. So example 1, let's copy it. 2x plus 10 equals negative 3x plus 30. Okay. Now, let's put our river in. Now, I'm probably going to contradict myself right here. I said there's 4 ways you can do it, and there is. But here's what I tend to do. I tend to put the variable on the left side and the constant on the right, just because that's what I'm comfortable with. Okay, so with that said, my method of choice is going to be to add the 3x to both sides, just like that. Okay. And I'm going to have 2x plus 3x, which gives me 5x. I'm going to bring down that plus 10 equals. Now over here, minus 3x plus 3x cancels out, and that leaves me with 30, just like that. Now, same last 2 steps we're comfortable with. We're going to subtract the 10 from both sides. So we're going to have 5x equal to 30 minus 10, which is 20. And then we're going to divide by 5 on both sides. So I've got x equal to 4. Okay? Now, checking. First thing we do when we check anything is write down our original problem. So I'm going to write down 2x plus 10 equal to negative 3x plus 30. And right here, I'm going to put in my river, just like that. Now, just like we did in the last video notes, I know that I'm going to have to do a little bit more work on this side and some more work on this side. I'm going to work with one side at a time with the checking, okay? So let's do the left side right here. I'm going to do 2 times 4 plus 10. All right, well, we know 2 times 4 is 8. Bring down the plus 10, but 8 plus 10 is 18. Okay, so this side simplified to 18 when I'm checking. Now let's go over here and check this side. So I've got negative 3 times 4 plus 30. Well, negative 3 times 4 is negative 12 plus 30. Negative 12 plus 30 is 18. Well, look, I've got 18 on both sides, so it checks out, and I know that is my correct answer. Okay, pause the video, make sure you've got everything copied down, and then we'll do example 3. Okay, now example 3, just different numbers. It's the same problem. Okay, so in example 3, we've got negative 4x plus 1 equal to 3x minus 20. I'm going to put in my river right here. Now, remember I told you I just tend to, and I guess probably my 8th grade math teacher taught me to do this. I usually put my variables over here and my constant or my numbers on the right side, okay? So I'm going to do that here. So I'm going to move the 3x over. Since it's positive 3x, I'm going to subtract 3x, just like that. Now I got to be careful of my signs right here. Negative 4x minus 3x is negative 7x. I bring down my plus 1 right there, equal to, now over here, those 3x's are going to cancel each other out, and that leaves me with negative 20, just like that. Now, next thing I'm going to do is subtract the 1 from both sides so that my numbers are together on the right side. So I've got negative 7x. The ones we know will cancel out. And negative 20 minus 1 is negative 21. Now, if I divide by negative 7, I'm going to get x equal to positive 3. And just kind of ran out of my paper block there, but that's okay. Now, let's check positive 3. So first thing we're going to do, of course, is write that problem down. So negative 4x plus 1 equal to 3x minus 20. Put your river in, just like that. Now, again, I'm going to simplify each side separately. So let's do the left side. So negative 4 times 3 plus 1. Negative 4 times 3 is negative 12 plus 1. Negative 12 plus 1 is negative 11. Okay? Now let me scoot over here to the right side and let's do the same thing here. It's going to be 3 times 3 minus 20. Well, 3 times 3 is 9 minus 20. 9 minus 20 is negative 11. Notice, yep. They all checked out. They're all exactly the same. And that means this is my correct answer. Now, once you get the notes copied, put them in your interactive notebook, and then you can go to Canvas and work on the assignments go with this. These notes will follow you for 3 in-class assignments.